So let me go back to Google. Images. Right, so we'll pick an image here, and so this this type of thing is like inserted into one another. Right, so if I view this image, right, if I basically copy this image, if I can copy, right, and go to something like this, like some simple editor, right, and if I bring this in, right, so now I will basically just use a couple of them, right, just say this one, and we'll get rid of these guys right here. Okay, so you know, these dolls, the idea is that they actually they're made up of two parts, right? So the two parts basically separate like this, two parts separate like this, and so this one can be inserted inside the other one, right? So essentially, when this is hidden inside, then basically when this is put back together, you don't see anything but one doll, but inside there is another doll, because they separate, and you can basically, it's hollow inside, so it can be made as an insertion. So this is what I'm trying to demonstrate. This is the way inheritance works. So inheritance is this, inheritance. Inheritance. In inheritance, we have two classes. One is called base, and another one is called derived, right? So derived is this bigger box, and base is this smaller box right here. Okay, and what happens is that when you try to diagram this, this is where that hollow triangle comes from, right? So we say that we want to create the base class and the derived class separately. We would like to design these classes and decide what they do. But when we actually do put them together, when we create an object, say of type dog, okay, this object will be constructed, its constructor will execute, it will take whatever parameters we pass to it, but as a side effect, a pet object will be also constructed inside this thing, right? So if we have this class named pet, this is the object of type pet right here, right? But when we construct a dog, automatically the pet will be also constructed. And typically, right, so I added constructor for the dog and for the cat, and I said that I want this type of relationship, right, which is called inheritance, and I said that I already designed class pet, but at this point I would like to be able to operate at the level of dog and cat, and I create these types of relationships. So once again, if I redraw this, right now, what we're trying to implement is that we have a pet class fully designed. Now we're trying to add a dog class and a cat class, okay, these two classes. And we're going to create these relationships, right? In software, we say public, right? Public, because in the code, this is how it looks like in the code. But at design time, we say that we would like to design pet class, dog class, and cat independently, but we will establish these relationships, which will allow us to do a lot of interesting tricks with these classes. So let's finish the constructors. Okay, let's finish these constructors. What I'm going to do is that I'm going to go to my implementation file. I just keep copying and pasting everything into this pet license.cpp class, right? So I'm going to take this class, I'm going to take these constructors, right? Dog constructor, copy and paste it here, and I'm going to take the cat constructor, right? Copy and paste over here. As before, these constructors, the dog constructor belongs to the dog class. The cat constructor belongs to the cat class. Okay, so I do this. Then, if you recall, we instantly get rid of the semicolon because we're trying to provide the actual implementation, and we will use we'll just use empty version of it. And so my challenge is, let me just align this a little bit better, okay? My challenge is this. When I say new dog, right? New dog, and I want to construct new dog with whatever parameters. The dog object is constructed, right? The dog object is constructed like this. But I know that because we're using this type of relationship with pet, an instance of a pet is also created inside this box, right? And what I need now is to be able to control creation of this object, right? I'm already controlling construction of dog and cat because I'm actually adding these constructors, but in order for me to control the creation of a pet, inside dog and cat, what I need to do is that I need to call constructors for a pet, right? So I need to say, pet, I want to construct you with this list of parameters, pretty much name, age, and color, right? And adoption indicator, right? So I need to be able to invoke constructor for a pet at the same time when the dog constructor runs, and likewise at the same time when a cat constructor runs. And guess what? This is done through the initializer list syntax. Just add a colon as before and use the name of the class to, which is our base class is pet, and derived class is cat or dog, right? And the syntax for making sure that we control the semantics of creation of pet inside dog and inside cat by specifying that we want to invoke this constructor with these parameters. By the way, since we're no longer needing this type because we have dog and cat, I don't think we need this type anymore. I'm actually going to get rid of it, right? And likewise, when we use pet, I'm not going to use this type in construction of a pet, because pet is just a pet without any type specified. We don't know what type is anymore, because what we're going to be doing is instead we're going to be creating either a dog or a cat, right? We're going to be creating a dog or a cat, and that is direction in which we're moving. So let me see what other adjustments I need to make in this code in order to be able to compile it.